Saxon's Calculus Lesson 73 is about derivatives of inverse trigonometric functions and then what to memorize. So they start out on page 362 with giving you all of these formulas for the inverse cosines for sine, cosine, tangent, cotangent, secant, and cosecant. They are all similar, as you see. They are pulling aspects from a right triangle that I've listed here. And if the angle is the y and we label a side x and a hypotenuse a, then by Pythagorean theorem, this other side is created by the square root of a squared minus x squared. And those are the aspects that you see within these formulas. Now, I note that except for the tangent and cotangent, I don't have radicals in the denominator. I have what feels like a fairly basic one with dx over top of this other side. And for cosine, I've got the same thing happening, except it's in its negative form up here in the top, but the denominator's the same. When I switch to the tangent, I've lost the square roots in the bottom, and I've gone to plus signs, and I have extra letters here in the numerator with the a, and then in this case, the negative a. And then for secant, I have that same a and negative a carrying down, but now I've gained an x on the outside in the denominator. Now that's relatively complicated to memorize, so I would definitely have it in my notes to pull for tests so that you can just look to see what you need to use here. In the first part, there are examples 1, 2, 3, and 4, I believe, are all, yes, they are all create the equations that we were just given here. So I will look through example 1, but not 2, 3, and 4, because I think once you get the general idea of what they're doing, you don't need to continue to practice it over and over and over. So using this triangle as its reference, for example 1, it says y equals the arc sine of x over a, so that's this. And then it's saying find what happens when you derive this. And so we're going to take so originally this would basically be saying dy equals arc sine from x over a. So we're going to derive, so that's, I said dy instinctively, y equals arc sine of x over a. So when I derive, this gives me dy equals, and then one second. Before I derive, I need to fix this formula because I can't work it with the arc in here. So I need to switch it to being saying the sine of y equals, that's gone, sorry, the x over a. Oh, mercy. Now when I derive, sine goes to cosine of y dy, because we're attaching it as in the differential, equals, and when I derive x, that goes to 1, and since a is a constant, I'm keeping the 1 over a, but it's got the dx with it. Now, I need to solve for dy over dx. So the dy is going to stay on this side, dx is going to divide over to join it, so that's those two taken care of. Then the 1 over a didn't move anywhere. The cosine divided to come over here, which makes it 1 over cosine of y multiplying with. Now, the cosine of y, because I'm not yet looking like this, the cosine of y needs to be substituted. So what is the ca of the y? Well, that is the root a squared minus x squared over the a. adjacent over hypotenuse. So now 1 over top of this means I'm flipping it. So I basically have dy over dx equals the 1 over a times a over, I just thought it would be easier to see it, a squared minus x squared if I wrote it all out. So the a's will cancel, and that's leaving me the 1 over a squared minus x squared. So that's basically what I have here, 1 over the square root of a squared minus x squared. The only difference is here I have dy over dx, and this is in the derivative of the y part over here with the dx back on that side. But that is what they want me to do. So they repeat in example 2, they find arc cosine. In example 3, they find arc tangent. In example 4, they find cosecant. And then they didn't do the others, but it doesn't really matter. Part B, what to memorize, says that you need to memorize 2 out of this list. I guess they're thinking you can just manipulate to get the others, but it's this one and this one slightly tweaked. And so I'm going to write them down here as to what they actually want you to know. So d over dx for the inverse sine of u over a, so there's their big change, equals, oops, I'm gonna have to come down here because I ran into that answer, 1 over, so instead of the dx, it's back to the 1, the square root of a squared minus u squared, since it's u over a, not x over a, as you would expect, and then it's got the du over the dx, and then as you would anticipate, for the other one, d over dx inverse tangent of u over a will equal, and then they're going back to, we need the a as it is there, and then u squared plus x squared with du over dx. So it's just a rearranged format, but they're saying these are the 2 to memorize. Now, example 5 says if y equals the inverse tangent of the cosine of x, find dy over dx. So we are looking at the cosine of x part. Oh, I guess maybe I should write that for you. Y equals inverse tangent cosine of x, and we are substituting this as the u is what I'm trying to say. So then we can use, which formula is best? Yeah, this one. Okay, so we were deriving, there's our inverse, u is the cosine. So we are going to have a over top of, and the u is then cosine squared x plus shouldn't it be x squared? No, a squared. Oh my goodness, plus a squared. Yikes, where am I don't know what I was looking at. Yes, because the u is what I'm substituting. X squared, that's what I was looking at. Okay. Now, so yeah, I don't know why I'm having such trouble with this. When I've plugged it in, I'm waffling between whether it's this one or this one. Either one seems to show me an x squared. However, in this case, because I've done this u substitution for the u here, this should be matching this one, and the a is plugging in as a 1. And they're saying that they do the chain rule here. and that's part of why they're plugging this in as a 1. And I'm making this sound super complicated, and it really shouldn't be. So if I'm doing the inverse tangent and I'm plugging into their basic formula where it's a is 1, then I have 1 over top of, and this becomes a plus 1 as well. So see, it didn't really matter. And then my cosine was being squared when I plugged it in as this piece. But I also have to derive every part of the problem. That's the chain rule. So the cosine derives to negative sine. So that is multiplying by negative sine of x. So when you put the whole thing together, it is basically 1 over, no, not 1, negative sine of x over cosine squared of x plus 1. And that's its simplified version. Now that we've overly complicated it, let's see if we can uncomplicate example 6. If y equals the arc sine of 2x, find the derivative. So we're using the inverse sine, and so we're getting 1 over top of the square root of, and then it was a squared minus the u squared. So the a is plugging in as 1, squared doesn't matter, minus the u squared, which in our case is sine of 2x, so 2x, and so we're plugging in 2x squared, and then I also need to derive that 2x to 2, which is going to multiply with this top. So we now have in simplification 2 over the square root of 1 minus 4x squared. 2 over, yes. Okay. So hopefully the second time we did it, I cleared up any issues that you may have. The a's are going to go to 1s, and then whatever else you're just plugging into that memorized formula.